Hello, welcome to another episode of the Data Science Leaders Podcast. I am your host, Dave Cole, and today's guest is Katya Hall. Katya is the Director of Enterprise Analytics at McKesson. Prior to McKesson, she was the Senior Manager of Enterprise Data Science and Analytics at CUNA Mutual Group. Welcome, Katya, to the DSL Podcast.
Hello, thanks for having me.
Great. Well, on today's episode, we're going to be talking a little bit about your I love delving into unique origin stories on how you became a data science leader, because I think there are a lot of folks out there who are wondering if they themselves can be a data science leader. Maybe they, don't have a PhD in stats and are wondering, if they can. And I think, your story is certainly unique. I mean, you started your career more as sort of an engagement manager, right? And now are in a DSL role. So we're going to delve a bit into that. I also want to talk about data science portfolio management. I think, what is a portfolio when it pertains to data science? We're going to delve into model risk management. I think there are a lot of companies, especially in the regulated industries, that know model risk management very well. But if you're not in the regulated industry, there's probably some great lessons learned in sort of understanding that whole process and why it's important. And then last but not least, we'll delve into sort of an area of expertise for you from a data science perspective and talk a little bit about the supply chain. So I sometimes like to hear about some of those interesting use cases and sort of learn about topics that might be sort of universal from a data science perspective. Like many companies have supply chain challenges and how data science is being applied. So great. Let's go ahead and just start off. Like I want to hear. So Katya, how did you make that leap from engagement manager to DSL? Like talk me through that. Was there a seminal moment? Like talk me through how that came to be.
Sure. So being an engagement manager, of course, I felt like it prepared me for working with business customers, understanding their problems. We did a lot of process optimization type work in an enterprise setting. But that leap really happened when I was at CUNA Mutual Group, and it was one of those serendipitous moments. First of all, I attended a presentation by our chief digital officer at the time. And he spoke about data science and predictive modeling, prescriptive analytics that they did back at Capital One. And it just really blew me away. That's how I feel I was bitten by that data science bug at that time. It just seemed like black magic, totally fascinated with how you can take a lot of data and predict the future just so accurately. And my background was in macroeconomics, but this really takes that data processing, data understanding to a different level. It's a leap from statistics, from econometrics into data science. So from that fascination, I ended up running into him. Harsh Tiwari was our chief data officer, and just chatting him up about opportunities to work in his area. I knew that I could bring a lot of that organizational expertise, problem solving, working with the business, being that translator into the mix. And my missing component, I guess, was the data science knowledge and understanding, at which point he and his team pointed me towards a training that I could take. So I went and enrolled in a couple of online programs. First, I did the Johns Hopkins program, Data Science for Executives, and or Data Science Management or something like that. And then I did a Wharton Business Analytics and Data Science program at Wharton School of Management. And it was kind of a crash course. You don't become a data scientist from attending a program like that, but you start to really understand the art of possible. What can data science do in an organization? What sort of problems it can and cannot solve? And kind of the realities of data science in the real world, and how to manage a team of data scientists. What are some of the pitfalls of that? So it was very educational. And so I was able to jump aboard the data science team, and my role initially was model risk management and kind of portfolio management. And eventually it evolved after a year into that translator role where I worked with our sales and marketing folks in the B2B sales area and helped them solve some of the problems around understanding customers, doing customer segmentation, and how do we take the insights from customer segmentation and create action from that that's beneficial for the business.
And we're so, I mean, first of all, it takes a lot of, grit and a lot of effort, right? For you to take an online course in addition to your day job. And so clearly, when you mentioned that you were bitten by the bug and sort of data science, that's quite the, that's quite the bite. I mean, that's good. So I think I'm impressed. First of all, I'm very impressed with that grit and determination. But then it sounds like you had an opportunity, to actually work with the sales side. And so in that training, it sounded, when I hear executive course or sort of management training, my guess is it doesn't delve too deep into like the hands-on sort of data science work, but I could be wrong. Did you actually, for some of these projects you're working on with the sales team, were you actually doing some of the data science, or were you sort of managing the projects and you had a team of data scientists? So how did you cut your teeth?
It's a double question from you. It has two sides. So as part of the training, there was some hands-on work. So we did build some optimization models. It wasn't anything particularly sophisticated, but we kind of you get a feel for how to build an optimizer. And you learn a lot about concepts. So you can talk the talk, don't necessarily walk the walk. So you're still heavily leaning on the team of data scientists. But you also learn how to best support them, how to give them the right tools, the right space and time, and how to talk sense into business, to protect this team, because the business will try to misinterpret sometimes the insights that you give them.
Not intentionally or unintentionally. I'm sure
right.
It's unintentional, right?
They'll work themselves into a corner, and then so there's a lot of art and science in even managing the process and the business and the team. So I felt like I could contribute to that. I never personally wrote code for the customer segmentation model. So it was more managing the process and making sure that those insights are being adopted. And it was extremely interesting learning for me to see just how many different avenues you can take customer segmentation insights, how many different uses there are. And it's kind of a foundational analysis that ends up growing a lot of additional insights on it, depending on who's applying the segmentation. Is it, people in customer engagement, is it marketing, is it sales, is it underwriting? So there are different users, and then they start to customize it. So it was more of the product owner role at that point in time.
Yeah, I mean, with customer segmentation, like the goal typically is to, first of all, better understand your customer, better understand what products they're interested, what. For product A, what does the customer look like that purchases product A, product B, et cetera? And it could be, to figure out what is the right marketing message that will resonate with them. It could be to figure out, what is the right approach from a sales perspective. Should you first hit them with a direct mail campaign or email campaign before you talk to them? So by better understanding your customer, you can better understand how you can engage with your prospect, not just a customer, but you can better understand how to engage with them. Like, do they want to engage online, or do they want to engage over the phone or other ways, right? So there's just so much you can do with that customer segment, by better understanding your customer. So it's interesting that you sort of brushed over something that I think is something I want to delve into, which I think is really important, which is you said, like, sometimes working with the business side can be challenging, and that's something that comes up time and again, right? If you're a DSL, which is managing expectations, it's properly being able to communicate status and obviously results, right? So are there anything any sort of words of wisdom that you have for other DSLs out there in terms of being able to work with business counterparts? Like, what would be your 2-minute crash course look like?
I think you hit on that with managing expectations. it, you can build the model in a day, but it takes a year to build a really good model, so
Right.
at least, so kind of setting correct expectations with the business is definitely key, but also interpreting the results, boiling it down, because you're communicating to lay audience, and you're talking to them potentially about them uh, giving you access to their sacred process that they manage, where their job is on the line, their career is on the line
Right.
if something goes wrong, and you're asking them to trust your data, trust your model, trust your insights, and go ahead and execute on what the predictive or prescriptive analytics are telling you. It takes a lot of trust. It takes time to build that trust, and probably it starts with building some credible descriptive analytics for them first, so that they can
Yeah.
start trusting your data set, your understanding of their domain, your understanding of their business. They feel like they connect with you personally, frankly, and that you get them in their business before they can start taking bets on the predictive insights that you are providing them. So my other piece of advice would be patience. Be patient with your business customers, because to build that true impact, sometimes it will take some time and trust and relationship building. I think that is key. But also challenge them, push the business to take that action. And sometimes things we've had to do is we would actually illustrate through data the cost of inaction to the
Right.
business.
Oh, that's a good.
Yeah.
That's
So,
I
for
like that.
example, not taking the bets, not building inventory where we're forecasting demand spikes. We demonstrate omitted orders, and here's what it's costing you. Do you want to really keep sitting in your hands, or do you want to start taking
Right.
bets?
I like that.
Numbers speak
I like that.
volumes. Yeah.
Yeah, and you mentioned something in passing there that I think is really important to point out, which is one way in which to build that trust, right, is starting with descriptive analytics. So starting with maybe just simple visualizations of the data, and the data scientists actually saying, like, here's what I'm seeing just looking at the data. Does this look right to you? Here's the distribution of orders by, some customer demographic, or, some customer segment that you've built out, or, does this look and feel right to you?
Mm-hmm.
And then you start that conversation, right? Then you have the folks on the business side. Yeah, that looks about right. That's what I would expect to see. Or no, that looks a little off. Like, I want to drill into that. I want to learn more. And then
Mm-hmm.
you have a dialogue and a back and forth. And as you go through those conversations, I imagine the data scientist is learning a heck of a lot, right, about
That's right.
just how the business has worked traditionally, what sort of gut instincts are out there. How are those gut instincts right, or are they maybe sort of need to be refreshed, no longer accurate? I think all of that is a great way to build that relationship, and then you can say, like, all right, now we actually want to build a model that is, I don't know, predicting something, or classifying something, or taking some existing process and using data science for it instead of maybe your gut instinct. So
Yeah.
I think that's great. And I
Absolutely.
also, yeah, and I think, here's the cost of not taking your medicine. I think
Yeah.
is a great insight as well. I want to talk a little bit about portfolio management. So I had never heard that concept as it pertains to data science, but I can imagine what it means. But I'll let you, like, what does it mean to you? Like, what is portfolio management?
Yeah. So it's the process that really allows you to take a bird's eye view of the body of work that your team has completed, what it's working on, what it's got in the backlog. You may or may not have a formal function called portfolio management, but if you're a data science leader, the odds are you're at least informally doing that already. You have a
Right.
list of use cases that you maintain. You understand what modeling methodologies are being used there. Who is the business sponsor of each of the use case, who's the business owner, who are your SMEs, subject matter experts, what data is being used, what tooling is being used for them. Is there opportunity to reuse those models elsewhere within the company, because the code can be reusable. Excellent models can be applied in different contexts. And what that allows you to do, having a more structured portfolio management, is to first of all see how your body of work is evolving, how it's performing. You can define key performance indicators for it. For example, how quickly do you turn around your work requests? How do they flow through the life cycle stages of a use case? How well are you doing intake? So when you sit down with a stakeholder to understand what they want from you in a model, do you really dig in and you understand the problem they're trying to solve or the opportunity they want to capitalize on? Do you structure your hypothesis very well so that you can then prove it out and say, here's how I'm going to solve your problem with this kind of model or an analytical approach, and really kind of improving the rigor of that. And then also, how do you monitor adoption of the use cases with the business? Good portfolio management can really shine a light on the lack of adoption, and then you can start to diagnose what's going on. Are you throwing use cases over the wall and saying, hey, I built a dashboard for you. Why don't you go play with it and tell me how you feel about it? Versus, hey, I've got a demand forecast for you, and here's the action you want to take with it. Please, would you go take that action? So you're giving
Right.
them a to-do list rather than an insight to play with. So then it's, and then you can start to track value that your insights are driving in the organization through that action that the business takes. And at McKesson, we've been able to implement a lot of rigor around that, which means we partner with the business and we build financial models around what value these use cases bring to the business. And then we bring in financial analysts who present the model and say, here's how we track value of the action business takes on our predictive models and insights. We take it to a pretty deep transactional level. So every holdout placed on the inventory, we can track any sort of buy or demand or a price adjustment. It can be all tracked through the data because we're already swimming in the data. We might as well build a dashboard that quantifies the business lift that is happening through the action. And then you can roll that up at a portfolio view. And the beauty of doing that is you're starting to create a complete value proposition for your data science team. You're saying, here's the dollars that we are creating for the organization. If you ever want to grow the team, you have yourself a platform of value to stand on. You can show the body of work. You can say, here's what we've done. Here's what we intend to do. We needed this many people to do this much. We can do this much more if we had these people because these are the opportunities we have scoped and this is what they're worth. And so it just makes a much more powerful value story.
So Katya, the picture I have in my mind, right, is there's some visualization, some dashboard, right, that shows all of the various, the portfolio of sort of model assets. And it could be anything from, it sounds like a visualization to an actual model, right? And then there's, and, maybe I'm inferring here, but some team that is responsible for putting this together and doing the financial analysis. I mean, one of the hard parts here, right, is actually being able to tie the output of the data science team to a change of behavior, right? So this team is of folks, I think you called them sort of financial analysts, is sort of focused on looking at that change of behavior. Is there any, I mean, is there like an A/B test or something that's going on here? Like, how is that done? Like, how is the financial analyst actually being able to tie that change in action to, something that your team has put together?
Yeah, so let me give an example. So we have a predictive model that looks for patterns in the data that will indicate supply disruption. So some kind of upstream supply chain event is happening. There's a ship that's stuck in the Suez Canal and a slew of pharmaceuticals are impacted. All of a sudden we can't get metformin in the building. So and then the model predicts that we actually have a very accurate model, probably in the 95th percentile, that it's always come through for us. And when we bubble up these disruption predictions to our purchasing, we know what action they're going to take. Is they're going to buy the product before it's disrupted, before it disappears off the manufacturer rosters, formularies rather. And when they buy it, that's quantifiable inventory that they will then sell through, and that revenue or the operating margin, whichever way we want to track the value, That's something we can quantify. We can see it very easily. We know the product. We know when we gave them notice. We know how much they were able to buy. We know when it did go disrupted. We know when it all sold because we have all the data from the enterprise resource planning system. So we can then quantify it ourselves. So the data scientist who built the model, I mean, he's the interested party to say, oh, here's the value that it produced. And then we have the business look it over. We have finance look it over. And then finance will validate the approach and say, yeah, this makes sense. You're quantifying revenue correctly. This aligns with how we do, P&L statements. This is kosher and good. And we get everyone's alignment. So this is a defensible number that we can then put on the books and say, supply disruption model, delivered X millions of dollars worth of margin for McKesson.
So the data science, in this case, in this example, the data scientist is actually responsible for putting together the analysis of like the ROI, for lack of a better term,
That's right.
That the model put together. But then the finance team is sort of responsible for blessing the method and the approach.
That's right.
Do I have that right? Okay.
Yeah.
Well, and then at the end, and then at some point, right, like you're aggregating the value in some way, shape, or form into some sort of like a cross portfolio view, I imagine.
Exactly.
Is that okay?
That's exactly
and then
right.
so by portfolio management, it's like that ability to look across all of your sort of data science. I could just call it data science output. It could be models. It could be visualization, and being able to to see like where you drive in the most value. And I imagine also there's some stinkers out there, right? There might be something that some model that's sitting out there that isn't providing a whole heck of a lot of value. And then like, what do you do in that case?
So we accept that a lot of the portfolio constituents will not deliver value, and some of it is accepted from the get-go, that it's just something informative. It might be just a report that helps the business operate, that they've already been doing. Maybe we automate it for them. We call them relationship builders. We make your life easier. We get to know your business. We get to know your data. We will then recommend an opportunity for you to have a truly impactful, robust, predictive model as we get to know if there's an opportunity to do so. So not everything is going to create value, and that's okay. We do prioritize work that does create value. As soon as we see an opportunity, we will definitely want to push it forward. We will alert the business that there's an opportunity. Sometimes we find those opportunities. Sometimes the business will bring it to us and say, hey, we have this inefficiency here. Can we work with you to solve it? So it's kind of bi-directional. And sometimes we think it's going to deliver value and the hypothesis doesn't check out. We do a proof of concept or we do a pilot and the analytical solution doesn't solve the problem for whatever reason. It just doesn't work sometimes, and that's okay. So we fail fast. We recognize that, we pivot. Maybe we change our approach. Maybe we didn't have the right data. That happened to us once, where we were sourcing retail insights and the data just never quite materialized in the richness and the volume that we were expecting. So we put the whole project on hold, and we went seeking additional third-party sources, and we weren't able to pursue it. So things, curveballs happen, and that's another thing of portfolio management. You create a forum to make those decisions. How is this project going? Where are we? Are we stuck? Are we moving forward? Do we have unsurmountable dependencies here? How can we help? Which levers can we push to keep the project team engaged and energized and moving in the right direction? So that's another thing, is having those place to have those conversations to keep the value moving forward.
Yeah, I mean, you mentioned conversation. I imagine that there's lots of great conversations around, where should resources, be placed, based on taking that portfolio view. And also, seeing that, like, I don't know, maybe you imagine you identify inefficiencies in the sense that you have maybe similar models that maybe could be some consolidation opportunities, right? By taking that portfolio view. So I think this is a great recommendation to all data science teams out there, is to take that, portfolio view. And then and I wanted to segue into the next topic, which is talking a little bit about model risk management. So first of all, like, just help our audience understand, like, what is model risk management?
So that's actually a pretty robust discipline, and I think it originated in the banking sector primarily, and there's quite a bit of regulation around it. I think it's called SR 1107. There's it's a whole playbook for how to do model risk management, and it's surprisingly readable. You can draw a lot of insights.
That'll be my next bedtime reading.
Yeah, there you
for
go.
sure.
You can't
Yeah.
sleep at night.
Yeah.
No, but model risk management, essentially keeping your models accurate. It's like a model hygiene, keeping your models running well and healthy and accurate. And there's a surprising number of variables and factors that can impact that accuracy and can derail your models. The good old garbage in, garbage out, of course, data quality. But then also you're relying on the platform and tools and a lot of moving parts there too from, if you look at your end-to-end data flow through the modeling environment, things can go wrong from the initial SQL query all the way through, the scoring algorithms, all the way out to egress to your downstream applications. A lot of moving parts, so things can go wrong. And part of model risk management rigor is to really examine that end-to-end flow and find what's called failure modes and effects. And we did these exercises. They're fascinating. How you can really visualize the entire flow of data and find, and people who work in the environments, platform engineers, cloud engineers, data engineers, data scientists coming together and thinking through it in a safe place, saying, okay, guys, what can go wrong at this step? And before you know it, you got a list of 30 steps and 50 risks of things that can go wrong. And then, and a lot of them, they will tell you have gone wrong if you give them a safe space. And then understanding, how do you prioritize controls? So how do you plug those holes and soft spots in the process where things have gone wrong? Do you create a test suite that runs every time you merge new code? And then that's your merge criteria. Before you merge new code, you have to run through tests. And do you have test your unit test coverage? Do you have good coverage so that you're not leaving any parts, any packages untested on merge and regression testing? And so a lot of different controls can go, and there's diminishing returns, right? You can control the heck out of the whole process to the point where you're not building any models, you're just doing controls all day long, right? So there's that sweet balance, sweet spot, risk appetite that you have to determine what you are comfortable with within your context environment. Is it life or death? Are you curing patients in an ICU, or are you doing, a marketing campaign? How expensive is your marketing campaign? How many dollars are in the line? Quantifying the risk is important. And we were fortunate enough, we were in the insurance context, so we had access to tremendous risk management professionals, actuaries who sat down and looked at the process with us and said, here's how much risk is trapped in here. Here's dollar values. How much is trapped in here. If you do this, you can slash this much risk off, squeeze it out of the process. So it was like, wow, okay, we know what to do now. So that was pretty.
So just to summarize, I think the first step is getting the various members of the team together who are actually responsible for producing the final output, the final model. And obviously that's the data scientists, but then you have, cloud engineers, ML engineers, and other sort of counterparts who are all involved in this process. And you get them together, you get them talking about what are all the potential failure points all along the way, right? From the, drift in the data to, maybe not receiving some data feed to, model going down, that is doing some, real-time scoring or what have you. And then trying to, identify, once I've identified all those various failure points, then that will inform how you go ahead and you test the model. It'll also inform what controls you put in place to try to mitigate the potential risk of, if this failure were to happen, like how do we get alerted so that we can be proactive about, fixing and resolving it. All of this is, but all of this needs to be balanced against speed, right? You have the risk and what your appetite for risk is. So the use case, the actual problem that your model is attempting to solve. If it were to have a catastrophic failure, like, what's truly at risk, and that needs to be, that risk needs to be balanced with your ability to be agile, right? Your ability to quickly retrain the model and to keep its accuracy high, let's say, or just get it out into production because it's going to have some obvious lift over the previous process that you might have had in place. So
exactly.
But if it is life threatening, if it is like a critical model, and then I imagine the amount of testing and the amount of rigor that goes into the controls, that whole length is of critical importance. So
exactly.
Yeah. And I think this just sort of this belief that that really only the regulated industry really needs to think about this. But I think there's like a lot of lessons learned there around model risk management that should be applied to all data science teams should be thinking about model risk and should be thinking about these controls and monitoring and looking at the data coming in and right. I think it's pretty universal.
Yeah,
right?
I would agree with you. And the most hands-on experience with deploying model risk management I had, yes, it was a regulated industry, but the main reason why the model risk exercise really bubbled up to the top priority for us was because of the dollars we were losing. Because at some point when the model reaches a certain level of adoption, the business is really placing bets, millions of dollars on the predictions that the model is providing. So then your risk will grow with that. And it was a marketing campaign that unfortunately crashed and burned because of the model risk problem. And it was actually caused by failure in master data management that we went through system migration. We moved our master data from one system to another, and it created false new leads in the system. So some folks, it had an exceptionally conservative fuzzy match algorithms, which created a lot of, it created duplicates that the scoring model did not recognize as recipients of past campaigns, which of course are going to be less responsive to your campaign.
Right.
And rank them as brand new, fresh meat leads, and put them at the top of the campaign. And of course, that wasn't very effective compared to any previous campaign for years. And so understanding that that's a link in the chain, master data management is a link in the chain that can fail you in an ugly way. So that's about understanding that entire environment, what impacts your models. But so that's the end-to-end, but also, of course, model validation, having what's called effective challenge. So having another data scientist come in and be able to reproduce the model from the ground up, from nothing, retrain it on a fresh data set and see if they achieve.
Just from the documentation and from the different sample data set. Yeah.
Exactly. Reproduce the steps laid out. That validates the documentation was accurate. It validates that the model research is reproducible. Very important. You're getting the same results. You're getting the same accuracy, same rankings and predictions. That's critical. That takes a lot of work. It takes a lot of commitment. So you're not going to do it for every single model. So that's where the model inventory comes into play. You catalog all your models and you go through, you rank them in terms of importance, financial impact, how critical it is a reputational risk in there, is a monetary risk in there, and then you create kind of, here's a top tier of models, nothing can go wrong here. And that's where you're going to put all your rigor and effort to validate the models, to scrub the environment, put all the controls in, that the data flows cleanly through that tier, and the rest can be a little more loose because you just don't have unlimited resources, right? So
yeah, that makes perfect sense. Let's segue into the last topic here, which is sort of an expertise of yours, just talking a little bit briefly about data science and how it applies to the supply chain. So what are some of the typical supply chain related use cases and challenges that you think that any company that has supply chain in its mix, like any manufacturing company, et cetera, like should be thinking about and sort of using data science to apply to the supply chain challenges?
Sure. So we have a supply chain center of excellence in enterprise analytics, so focused completely on all things inventory management, labor management, transportation management, kind of the three main pillars, so to speak. And distribution center operations is also part of that, of course. I would say we've done the most use cases to date in inventory management space. So concerning demand forecasting, getting really good at longer term demand, 30, 60-day demand, so we can communicate that to our suppliers upstream. And get their commitment to supply to those levels. So we've really improved the accuracy of those models. And it forms a binding commitment with our suppliers. They have to supply to that level. And it's improved our inventory positions because of the accuracy. So that's one. Then short-term demand forecasts so that we can respond to things like COVID-19 outbreaks regionally. So we have a model that monitors patient dispense regionally and responds to that patient demand, and then we can move inventory to where the outbreaks are happening. And it doesn't have to be COVID. It can be seasonal allergies. Pollen levels all of a sudden spiked over here in Georgia, and so we move the right product there as needed. So that's more of a short-term forecast model. And supply disruption is a really big one. We've got an ensemble model running there, monitoring purchase order fulfillment patterns upstream from suppliers, and then they monitor like products. So they're products that kind of correlate, they move together in a disruption pattern. This guy gets disrupted, then this guy, and then so you monitor for
right.
that.
So this part of the supply chain gets disrupted in some form or fashion, then this is how it impacts supplies downstream. Is that right?
Yeah,
or inventory
kind of.
downstream.
So that's something where we're branching out now to start looking at externalities like, shipping disruptions or port disruptions, or, manufacturing in India, API, ingredient manufacturing. We're starting to really partner. We have Global Security Operations Center, and they monitor several different locales stateside, but also abroad, looking for different weather disruptions, social unrest, and security things. And we're starting to look and see how we can translate that into supply chain disruptions. How do we connect the dots from geography to manufacturers to products, so we can weave that fabric of supply chain understanding and be even more, have greater lead time in anticipating disruptions for certain products. So that's kind of something that we're starting to look at now. And then transportation, just having transparency of movement of goods. Are there route optimization opportunities? Are there ways we can just ultimately save money for patients by being more efficient as to how we move goods? We're playing with a concept of a distribution network digital twin. So we're simulating how our network will respond to different sort of external factors, demand fluctuations, supply fluctuations. If we try out different configurations of customers dedicated to certain distribution centers and products, and so playing it out without changing things in the physical world, can we do that digitally and arrive at an accurate representation of what that could look like? So that's something we're working towards. We've got a version of that on the inventory side. So we're working to improve and expand on that. And the latest cool thing that we've done is we're just getting started on an initiative to take sensor, spatial, and video data in distribution centers and convert that into structured data and insights, and be able to catch things related to risk, security, and inefficiencies. So that's a pilot that's spinning up right now that we're pretty excited about.
That's great. Wow, I learned a lot in this episode. We started out talking about just your career and how you became a DSL portfolio manager. We talked about portfolio management. We talked about model risk management. And finally, talking through some use cases with regards to supply chain and how data science is being able to improve the flow of goods and making sure that inventories are always kept up to date in order to satisfy patients and have a great customer experience. So I thoroughly enjoyed it, Katya. I learned a lot. Thank you so much for being on the Data Science Leaders podcast. Is there a way in which people can get in contact with you if they have any follow-on questions?
Yeah, I'm on LinkedIn. Just look up Katya Hall at McKesson, and I'll be happy to chat with you and answer any questions you might have.
Fantastic. Well, thank you so much for being on the Data Science Leaders podcast, Katya. I appreciate it.
Thanks so much, Dave.
Take care.